Okay, so like I said, just for the sake of the recording, the test is not on Tuesday. It's on Thursday. We are still for sure not having a midterm in this class. That is the way we're going to roll with things.
The final is going to be over everything?
Quite possibly. It'll be so fun. You'll love it. All right. Number 2, pi over 3. Number 4, pi over 6. Number 6, pi over 2. 8, pi. Number 10, pi over 3. Number 12, negative pi over 3. Or you could have done whatever that was. It dawns on me a little bit in some of these that I didn't say real clear that some of them technically have more than one answer, and whether you write it positive or negative would matter. Like this would be whatever that would be. It'd be 2 pi minus pi over 3, so 7 pi over 3. If it was the positive version, which on a test I will tell you what it needs to be. Like write the positive version of the answer or whatever. But anyway, continuing on. Number 14 is 0. Number 16 is either pi over 3 or 60 degrees south of west. Excuse me. Number 18 is on.
We didn't do 18.
Oh.
We did 2 to 16 and then jumped.
Oh, yeah. Yeah, no, we're not graphing inverses. Still, that's still the plan. Great idea, love it. Number 30 is pi over 2. 32 is pi. Number 34 is pi over 3. 36 is 0. 38 is negative square root of 2 over 2. Number 40 is negative 1/2. 42 is square root of 1 minus x squared all over 1 minus x squared. Number 44 is the square root of 1 minus x squared. Excuse me. Number 46 is the square root of 1 minus x squared all over 1 minus x squared. And 48 is the square root of 1 minus x squared over x. Where do y'all want to start with your questions?
Number 2.
Number 2.
I felt so down today. I looked for hours. Not hours, that's dramatic. I looked for an hour for a video on this because I couldn't figure it out, and I completely forgot that you posted the video of this class from yesterday.
I see.
Because I should have watched.
There you go. Square root of 3 over 2, yeah. Okay. Where is sine square root of 3 over 2? And how many degrees?
Oh.
Chart. From the chart.
Oh.
When
It's 60 degrees.
at 60 degrees or pi over 3. So the answer is pi over 3.
And pi over 3 is the other thing.
It's radians, yes.
So would it be helpful to
Know those? Yes.
write the chart with the radians or write it with the degrees?
My answer would be yes.
So both.
Yeah. I would get in the habit of doing both. Okay, what next?
Number 10.
Number 10. Excuse me. The inverse cosine of 1/2.
Why do you have the triangle right in that quadrant?
I have no idea. I don't know why I did that. I was just starting to label stuff, and then I kind of realized I was doing something weird. How about that? That seems a lot more reasonable. Where is the cosine 1/2?
60 degrees.
Pi over 3.
That's just the answer.
Yeah.
Okay, overcomplicated it. 12 I did have issues with as well, because tangent.
I think I understand, but I'm 10 million times slower than you are.
Okay, so the inverse tangent of 0.
No, that's 12, not 14.
Inverse tangent of negative square root of 3.
Why is it in that quadrant?
You tell me.
Isn't that the cosine quadrant?
What is tangent? And y's and x's and r's?
Y over x.
Y over x. Negative square root of 3. Over 2.
Where did this 2 come from?
I don't know where the 2 came from. I don't know. I keep writing weird things. How about a 1? Sorry. I don't know why. I don't know why my brain keeps writing strange things. I promise it's not to like randomly confuse you. I wouldn't confuse anyone on purpose in math class.
Okay, and then do we need to figure out the hypotenuse?
We need to figure out this angle.
It's just the negative of whatever it is on the chart.
It is.
Negative pi over 3.
Negative pi over 3.
Why is it negative?
Because it now, so we have 2 options, and this was what I was talking about. So if we're drawing from here this way, it's negative pi over 3. Now, if the instructions were to say, write the positive exact value, then it would be positive 7 pi over 3. Is that right? That doesn't sound right. Is it 8 pi over 3? No.
5 pi over 3.
Yes. That's the what I'm trying to say. Yeah.
Okay, that's making more.
And those are the same angle. The negative pi over 3 and positive 5 pi over 3 are the exact same angle. They're just coming from different directions.
Okay, let's do 16. Work from?
Sure.
Yay.
Cruise ship sailed due west. When I taught physics, we would do problems like this where we would have to convert when we did displacement and whatever, we did adding vectors and stuff. I would do a problem where I would actually go out and walk in the field thing where they had to, and I gave them the different bearings, and then they had to do the math in class to turn it into one bearing, and then they would all go out and walk with a compass and see whether they ended up getting the prize or not. The prize was usually some kind of candy. Cruise ship sailed due west before turning south. Due west, turning south. Due west, 24 miles. This is 24. When the cruise ship became disabled, oh no! The crew radioed for help. The rescue boat found that the fastest route was straight to them. Imagine that. 48 miles. Find the angle at which the rescue boat should travel to aid the cruise ship. They even label in the picture where the angle should be.
Is it gonna be negative x over r? Is that how we figure it out? Am I doing?
Yeah.
Okay. I think I didn't put
The
negative.
inverse cosine of 24 over 48, which would be 1/2, right?
Yeah, but then would the 24 be negative since it's going west, which is...
We always make r positive. R is always positive.
R is the hypotenuse.
Right.
I said 24, not 48.
You said 48, I think, but you meant 24?
Yes.
Yeah, negatives, but there, so we're going to take care of that in the way we write our answer. I'll show you on a word problem, and I'll show you what I mean here in a second. Because on this particular problem, I actually would prefer the degree answer on a word problem because it's more typical. So what is the inverse cosine of 1/2?
Pi over 3.
Okay.
Or
Pi over 3 or 60 degrees, true. So, or 60 degrees. Now, excuse me. So it would be negative, actually it wouldn't be negative pi over, it would be like whatever that would be, right? It would be, this is pi over 3. I don't know what's wrong with me this class. I promise I just had lentils. So that would be a pi over 3, right? And then so it would be pi plus pi over 3, so it would be 4 pi over 3, right? Would be how you'd write that in radians. But they're not, the ship's not going to be like, yeah, we went 4 pi over 3 to get them. They're going to be like 60 degrees. Well, 60 degrees where? So how do we describe that on a compass? We say that it is 60 degrees south of west. So the best answer, in my opinion, on this problem is 60 degrees south of west. Make sense?
no, yeah.
Good. What other questions do we have, folks?
36.
Okay.
What is that one?
It's a nice little compounded problem.
Nice little sad.
Got a few steps to it, but it's not so hard.
Wait, what is 90 degrees in radians?
90 degrees in radians?
Pi over 2.
It is pi over 2. This would be half a pi. So we're trying to find the inverse sine of the cosine of pi over 2. What's the cosine of pi over 2?
Square root of 3 over 2.
I don't think so.
I don't know.
0.
You didn't go far enough on your chart.
0.
0. So we're trying to find the inverse sine of 0. So when is sine 0?
Oh wait,
0.
0 divided by
At
2 is
0.
0.
Okay, I don't know what I was doing the first time.
I don't either.
42?
We don't need to do 38 or 40 or 38.
I didn't do them because that was the one that I was like, I'm not sure if I'm
So
gonna do
so we probably should do one of them, right? At least one.
Let's do 38.
Let's do 38. Do it. It's not actually any harder than what we just did. Actually, we're going to do 40 because 40's got more puzzle pieces, kind of. Well, I say that. It doesn't matter. Either one is fine. Oh, that's tangent. So yeah, sure. Why not? 38. We're going to find the sine of the inverse tangent of 1 minus, right? Yes. the inverse sine of 1. So what would we do first?
Find stuff in the parentheses.
I agree. Find stuff. You work nested trig functions from the inside out, just like you would in kind of regular order of operations.
What is inverse tan of 1? Because it's not on the chart.
Yeah.
Yeah, it is.
It's 45.
Oh, 45, yeah.
I think you copied it wrong. Looks like you wrote 1/2. Because it would be, because remember it's sine over cosine, so it's this over this, which would be 1. So the sine of 1 minus pi over 2. So the sine of negative pi over 2.
When did it turn?
Oh.
1 minus pi over 2 is negative pi over 2, right? No, 0 is. How about what's positive pi over 2? That makes more sense, doesn't it? I promise I'm not writing random crap just for no reason. I promise that's not what I'm doing.
Help me, I'm dying.
Did you do that last
And that's not even actually true, is it?
Can we write it out like fully? Because I am so confused.
I am writing it out fully. 1 minus pi over 2 is what we're doing, yeah?
Yeah.
So we need
How do we do
2 over 2 minus pi over 2, right? Right?
Yeah.
Which would be 2 minus pi over 2.
That's not on the chart.
I think we should do this in degrees. What do you think?
Yeah, I'm so confused.
I think it's going to be easier to do in degrees. What do y'all think?
Okay,
Yeah,
so
good
we
idea.
have
So the sine of sine of 180 degrees.
Why is that 180?
No, that's not right.
It's 90, right?
the first one's 45.
Pi over 2 is 90.
The inverse sine of 1 is 45 degrees. This is wrong.
Yeah, that was.
That's why it was being, okay.
This is fun.
We did the chart backwards and then correctly. So let's put it back to correctly on both. How about this is pi over 4? Does that seem more reasonable to everybody?
Yeah.
Oh my gosh. So that would be what? That'd be pi over 4 minus 2 pi over 4 negative pi over 4. That sound right to everybody?
Yes.
Okay, good. Of pi over 4 negative. Great.
Square root of 2 over 2.
Square root of 2 over 2 negative square root of 2 over 2. Because, look here, where is negative pi over 4?
1 second.
Wrong way.
Right there. Yeah? What is sine in this quadrant?
All students positive. Oh, negative, sorry.
Negative. So it's negative there. So our answer is negative square root of 2 over 2.
How do we know it's negative there?
What is sine right here in quadrant 4?
That's why I'm asking. I don't know.
Okay, what acronym do we use?
All students take calculus, but I don't. How does that tell you when they're negative?
Okay. I didn't realize we had that gap from last week. Okay, great. It's easy money. So it's telling you which ones are positive. All of them are positive. Sine's positive. Tangent's positive. Cosine's positive.
So if they're not labeled, then they're negative?
Correct.
Okay.
Correct. Great. Easy fill. A little spackle and we're there. Great. Now what?
42.
42. What a fun problem. I like these ones.
Oh,
I don't know if I am today. I don't know why my brain and my hands are just like all over the place today. What all have I eaten today? I ate lentils and I ate something else before that. Oatmeal is the oatmeal. I shouldn't have eaten the oatmeal. I don't usually eat oatmeal. Now we know. Don't eat oatmeal in the morning. 42.
Cosecant is scary.
Is it? Cosecant's so fun. We like cosecant.
Sine?
It's one over sine.
Inverse, not inverse sine, but
Reciprocal sine. The cosecant of the inverse cosine of x. Another reason why these are like ugly, right? Because they're not even numbers. So we get an ugly answer. Isn't that exciting?
yeah. Thing is, I think I followed what they did in the book, but I got it wrong, so I don't know.
Okay. So, how could we get there?
Okay, well, cosine is adjacent over hypotenuse.
It's true. It's x over r on the unit circle. What is r always?
Hypotenuse.
What number?
1.
1. Okay.
And then we just.
So how would we find this angle? I mean, this side.
Pythagorean theorem.
Is that what you just said? Yeah, we would use the Pythagorean theorem. We're looking for this guy. Looking for y, right? So x squared plus y squared equals 1 squared, right? And we need y. We need y to exist and be happy-pappy, right? So what do we do to solve for y right now?
We get rid of x.
Get rid of x squared, right? So 1 squared is just 1, right? We can all agree on that. So minus x squared. So y squared equals 1 minus x squared. How do we get rid of the square root?
We square root it.
Yeah, that is what we meant to be doing is we unsquare it. So we end up with y equals plus or minus the square root of 1 minus x squared. Now, if we're doing quadrant 1, there's technically 2 answers to this problem. This goes back to kind of what I was saying at the very beginning of this class. On almost all of these, there's multiple correct answers. We could even write an expression that gave us every correct answer. We could do this plus 2 pi and then 2 pi n, and then we'd have like all of them, right? But if we just assume the simplest possible, we assume quadrant 1, then we're going to chuck that in a bin, right? Because that would put us down here, right? So this is the square root of 1 minus x squared.
Okay, then we need to find the cosine of that.
We do. So what is cosecant?
It is 1 over sine or.
Right? So r over y, right? So that would be 1 over the square root of 1 minus x squared. Problem, red flag on the play. What's the problem?
Square root of
Square root in the bottom, so how do we get rid of the square root in the bottom?
Multiply by itself.
Yep. So we end up with the square root of 1 minus x squared all over 1 minus x squared. Blamio. Like I say, if we put plus 2 pi in, then that's all of them, right? So depending on what the instructions said, if the instructions said write all the exact values, you just add plus 2 pi in. If it was tangent, by the way, what would you, how would that expression change?
Plus pi n?
Yes, plus pi n. Yeah. Tangent or cotangent, right? That's your emotional sport galaxy pig. I don't know.
It's a rainbow cow.
Rainbow. Oh, it is a cow, I guess.
His name is even Nijishu, which means
I think it's a pig. Surely that's a pig nose. His nose
all
is
of the
clearly
pictures of
a
this
pig.
Look like a pig. They're not pigs.
Okay.
They're just bad at making noses that don't look like pigs.
I see. I see.
Just a little fella.
Just a little fella. Okay. What other questions do we have?
I'm actually finished, so what do y'all need?
What do y'all think?
Where would I go to study what all the things like x over r, and y over r, and y over x, all that sort of stuff?
Your
missed
notes.
that.
That is
Where
just-
is that?
It's like one of the first lessons. Yeah, the first lesson.
Like lesson 2?
No, lesson 1.
Oh,
You can also, Garrett, I'll remind you something very useful potentially. You can also just flip back and look in the lessons, right? All of those things, because it also gives it to you there. So that's another place.
Sine is x over r, correct?
Sine is y over r.
I think I'm confused on what r is radius.
Yes.
X is x.
As x.
Y is y.
Yeah.
What does that have to do with anything that? What do you mean? It's right here. I don't see anything to do with x's or y's right here. Or
No, not that one. The next lesson, when we get to the unit circle part. When we get to the unit circle part, whatever lesson that, let me look at my book. See, I'll tell you what lesson it's in.
4.2. I think I'm seeing it.
I thought it was 4.3, but I could be lying.
That's what is in mine.
I think it's in lesson 3. Yeah, trig functions in the unit circle. Yes.
Where's my 4.3?
I don't know.
That'll be good.
So in the book, in case this is useful information to you, it starts on page 242.
Okay.
You can also, Garrett, it might also, because like I've been saying most of this class actually, but it's also worth noting that you can get them yourself if you know the other ones, right?
Yeah.
Just draw this and put a theta right there. Which one is opposite theta?
That's over here.
Okay, so opposite, which is also y, I can do things, right? Which one's adjacent to theta?
Okay. My hypotenuse is, yeah.
The adjacent, which is the x, and this is the hypotenuse, which is r, right? And so sine is opposite over hypotenuse, y over r. Cosine is adjacent over hypotenuse, which is x over r. And tangent is opposite over adjacent, which is y over x. It's also one of the reasons why tangent is sine over cosine, right? Because if r is 1, then y over 1 over x over 1 is the same as y over x.
Yeah.
So is the same as sine over cosine, which is going to be a super, super useful identity that you're going to use a lot in the next unit. We should look at the time and make sure I'm correct. and not leave 15 minutes early this time. I don't know what I was thinking last week. Last class, we could have done more, like more notes. Oh well.
That's helpful.
This lesson is pretty easy. It's 2 formulas. So the last lesson in this chapter is very important because it lets us answer the question, what if it's not a right triangle?
Oh, gracious, gravy.
How are we doing geometry?
What? We're not doing geometry. Although you may have learned this in geometry, because I teach law of sines and cosines in geometry. But you're not going to have to do any proofs. That's next unit, kind of. Okay, so the law of sines and the law of cosines. And we're going to start with the law of sines, which is the one you want to use. So the question is going to be eventually, how do you know when to use law of sines and when to use law of cosines? That eventually is going to be the question. Here's my simple answer to that question. Are you ready? If you can use law of sines, use law of sines because it's simpler. But if you can't, use law of cosines. And we'll show you examples of where you can't, right? So the law of sines says for any triangle, regardless of whether it is a right triangle or not, for any triangle ABC, the sides and the angles have proportional relationships.
Where is this at? Page
291. Okay? And their relationship looks like this. The sine of angle A over side A equals the sine of angle B over side B equals the sine of C over side C. By the way, I think, let me make sure this is correct before I tell you otherwise. I think that I have a video on this topic in the geometry class stuff.
See, it is geometry.
I told you I teach it in this one in geometry. I said that. I didn't disagree with you this time. Oh my gosh. It's easy stuff. Maybe I don't. Maybe I just taught it in class this last year. Sine. Oh no, it's right there. It just didn't. Yeah, the laws of sines and cosines. It's right there. That's an 8-6 from geometry. So if you want an extra video of it, there you go.
Cool. 8-6.
It does exist. And it's the same topic. There's nothing really added to it. It's the same as before. So, law of sines is nice, simple, proportional relationship. It's easy to memorize. It's no big deal. Actually, once you kind of figure out what's going on in the law of cosines, it's not actually that hard to memorize either. Just don't try to memorize the law of cosines with letters. Just memorize it spatially. I'll show you what I mean in a minute. Because if you try to memorize the letters, then you're going to be like having a lot harder time. But if you just memorize, oh, it's that, then it's actually not that bad to memorize either. Okay. The sine of the angle or the side of its opposite side. Yeah, see? Just like all goes together. It's all pretty. It all matches. It's all easy peasy. What about law of cosines? Law of cosines, the law of cosines.
Yeah, now.
I think I might. I don't know. I don't know what's wrong with me. I'm broken. Law of cosines looks more complicated. It is slightly more difficult to work with, but not really. It's not actually that bad. I'll write it in its 3 versions of itself up here, and then I'll talk you through how I would actually go about memorizing it. Because it's not as difficult to memorize as it looks. A squared equals b squared plus c squared minus 2bc times the cosine of angle A. It would also be true with this triangle that b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Now before you're writing the third, unless you catch up, and then once everybody's caught up, I want you to stop and you tell me in your head without being out loud yet what the third one's going to be. Because I want you to stop and look at how the pattern works spatially. Because that's how to memorize it, not trying to remember the letters. Because it doesn't matter which one's A, B, or C. Everybody got something in their head? Okay.
I got it.
Is the uppercase letter on the other side, on the end of it, is that the angle?
Yes. Yeah. Remember, uppercases we use for points.
Yeah, I just didn't know if that was just sitting as or if it was a part of the equation.
Oh yeah, no. So the last one is going to be side c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. So the way we think about it is the side and angle there, and the ones around it. So side and angle versus the two that are adjacent to it, right? So if we're dealing with this one, then the angle that we're doing the cosine of would be the opposite. And the ones that we would have in here would be the other two sides. Okay. So cosine, with the law of sines, in order to solve it, you have to have one complete pair. You have to have like C and C, or B and B, or A and A. If you have at least one complete pair, you can use law of sines. But if you don't have at least one complete pair, you have to use law of cosines. Now you can always use law of cosines. Law of cosines, if you have all but one of these things in some arrangement here, you can use it, right? Law of sines is easier to mess with because it's a simple proportion. But in order to use law of cosines, you have to have a complete pair, right? How are we doing on time? We have time for an example, or do I need to point you in the direction of the video? I bet we have time for an example. Yeah, we do. We definitely have time for an example. Here we go. So we're going to solve the triangle. And if the instructions say solve the triangle, what it's asking you to do is it's asking you to find all of the missing parts. So all of the vertices, all the angles, and all the side lengths. That's what it do mean. And again, if it's a right triangle, don't use any of these, right? Use just like regular trig, easy money. Yeah? But these are not right triangles. So we're going to solve this triangle. We're going to solve STR. And it's got this information. 51 degrees is S. And R is 63 degrees. segment ST is 13. And segment S is segment S, and segment T is segment T. So we need to find angle T. We need to find segments T and S, right? So, give it a half a second for y'all to caught up writing. Okay, so we have a complete pair, right? We have a 63 degrees and 13. We have those, so we can use the law of sines, right? So the first part of the proportion, and remember that you don't always have to use the whole, like all three chunks, right? Because we can find angle T on this problem without any trig, right? How would we find angle T? That's
Add both of those other two and then subtract them from 180.
Yeah, that's 180 degrees in a triangle, right? Sum of interior angles. So 180 minus 63 minus 51 equals 66 degrees. So angle T, the measure of angle T, equals 66 degrees. So that's the first bit of our solvage. Always, by the way, this is just pro tip for math in general. If possible, always go back to given numbers instead of ones you calculated, and use the given numbers instead of the ones you calculated. Because if you made a mistake over here and then you use that number again, then you've made a mistake everywhere, right? So if you can, use ones that are given instead of calculated, okay? So the pair that we know is what we'll start off with. So the sine of 63 degrees, so make sure your calculator's in degree mode, right, over 13 equals the sine of 51 degrees over S. That's just a proportion, right? Cross multiply and divide. And it says in the instructions, round side lengths to the nearest tenth and angle measures to the nearest degree. So we do want the ugly decimal equivalent. So S equals the 13 times the sine of 51 degrees. Again, make sure your calculator's in the right mode, divided by the sine of 63 degrees. So you shove that in your calculator, push enter,
11.34.
and you end up with 11.34. It says to round to nearest tenth, so 13.3. No, what did you say? What did we say? 11.3. Yeah, 11.3. Oh, units. So you could put the word units if it makes you feel better. Probably be the most correct, but in this context, I wouldn't necessarily count off. So to get the other one, we'd want to, again, go back to given numbers. So we'd want to use this same part of this proportion, right? So the sine of 63 degrees over 13 equals, oh, we can't go back to given numbers, just kidding, LOL JK. So we've got to use the one that we calculated, the sine of 66 degrees over T. And cross multiply and divide, so T would equal, excuse me, 13 times the sine of 66 degrees over the sine of 63 degrees, and we would end up with 13.3 units.
Okay, that makes sense.
Easy money. That's what I said. And so actually, they're both, neither one of them are all that hard. I think law of cosines is just a little bit more confusing to look at and use. But law of sines is real easy money, right? So let's solve a different triangle.
I have to make sure I need the last.
No, you can't. It's not allowed.
Ontario.
Does it make sense since I was going clearly too fast on this problem?
What about R?
We had
R was given.
What?
Angle R and
Oh, yeah,
side
yeah.
R was both given.
the T just comes out to the side just because that's what we're solving for.
What?
It's like when after you cross multiply and divide, the T comes out by itself.
Yeah, yeah. Because you do 13 times the sine of 66 equals T times the sine of 63, and then you divide by sine of 63.
Oh, you just, I got you.
I just skipped a step.
I think I started to think that, but then I got distracted and didn't finish the thought.
Yep. All right, let's do uno más. Oh, sorry, I started at the wrong end. I thought you were done.
No, it's
Excuse me. All right, let's solve this triangle. Isn't it cute? It's definitely obtuse. Let's prove that it's obtuse by doing the math. 1.5 miles. Oh, just kidding, that's 1 mile on that one. This one is 1.5 miles, and this one is 2 miles. So solve this triangle. Find the missing bits.
We don't have any of the.
That's true. So, therefore, we cannot use law of sines. We don't have any pairs.
You have to have at least 2 of them, right?
What?
You have to have at least 2 of them, right?
At least one.
You have to have at least one set of an angle opposite a side to use law of sines. You have to have one connected set to use law of sines. We don't have that, so that means we got to use law of cosines, right? So, which angle do y'all want to start with, A, B, or C?
Start with A.
Sounds just fine. So, the one that goes with A is 1.5. So that would be the one that's by itself, right? So it would be 1.5 squared equals, then the other two added. So 1 squared plus 2 squared minus,
It's going to be 2 squared plus 1 squared?
it doesn't matter. That's what I'm trying to say, is don't memorize it that way. Don't memorize A, B's, and C's, not really. Memorize it in spatial chunks, right? This plus this is the same as this plus this, right? It's just the one opposite it going with that, and then the ones around it, right? So minus 2 times 1 times 2 times the cosine of A. What's 1.5 squared? 2.25. I think those are much easier to do in your head if you switch it over to an improper fraction, because that would be 3/2, and then squared would be 9/4. I think that's a lot more difficult to do in your head. Equals 1 plus 4 minus 4 times the cosine of A. Now, what would be the mistake that would be easy to make right now?
Algebra.
The 4 and the 4 disappear?
Yeah. An easy mistake right now would be to turn this side into 1 cosine of A and do 1 plus 4 minus 4 equals 1. But we can't do that. Why not?
Because there's a multiplier.
Yeah, because there's this guy multiplied, so we can't do that. All right, so what is the only thing we can do over here so far?
Cosine of
No, we can't get to that yet.
1 plus 4.
And this is 1 plus 4, right?
A. Oh, because 4 is a trash.
Yes. Cosine of A equals. Okay. And then what would we have to do? We can by subtracting, right? So negative 2.75 equals negative 4 cosine of A.
And divide everything by negative 4.
Divide everything by negative 4. We end up with a cosine of A equals positive something
0.6875.
0.6875. What do we need to do now to finish? Because we don't have A yet.
Inverse
Yes.
cosine of 6.
Yes.
0.6875 equals A. Because inverse cosine allows you to.
Find the angle. Yes.
And that's 46.56.
46.56. Let me see where it says to round to. What does it say? It doesn't say, so we'll just round at the tenths place like they do in the answer.
Okay, so 46.6.
46.6. And that's actually all they asked for. They are asking for something else. But if we were to solve for the other ones, like we were going to solve for C, then we would use law of cosines again, right? It would be 1 squared equals 1.5.
Wait, you said don't use the ones that you figure out with that. Never mind.
Yeah, and you would especially not want to do that here because not only do we have something we could have made a mistake on, but we have a rounded answer too. So we're going to compound our rounding stuff. Well, yeah, 1.5 squared plus 2 squared minus 2 times 1.5 times 2 times the cosine of C. And you would do all the math to get that one. And the same thing for B, right? Make sense? That's it. That's literally this entire lesson. Homework is, and I have another video if you want it. It's in the geometry thing. There are also other, oh, just kidding. There's one more formula. I forgot, there's two more formulas. Yeah. That's right. What time is it? Time enough to write down the formulas. I do have an example of using, I think it's in the pre-cal class videos. I have an example of doing a problem with Heron's formula. Yeah. It's in there somewhere. Yeah, there's two formulas. They're based on laws of sines and cosines, which is why they're in this unit and lesson, excuse me. So Heron's formula, both of them are for finding the area of a triangle.
Is that his name?
Probably. Says if we have triangle A, B, C, you can find the area by taking the square root of S times S minus A times S minus B times S minus C, where S is 1/2 of A plus B plus C. So you can find, so Heron's formula lets, if we have only the sides of a triangle, we can do it so you don't have to have the height like the old school formula, right? That's what it says. Then if you're given a side, two sides and the angle between them, area, then there's a different formula that's even easier and it looks like this. Use the same triangle, make our lives easier. 1/2 of the two sides that are adjacent. That's why they wrote out area, because that's not that angle. That's why, that makes total sense. Area, 1/2 of B times C times the, sine of the angle in between those two, right? Which if you wrote it with the others, it would be the same idea, right? 1/2 of A times B times the sine of C, and then of course the last one would be the same. But with other, 1/2 of A times C times the sine of the angle in between them. And this is just like in law of cosines. If you memorize this just by, it's 1/2 of the sides that are adjacent times the sine of the angle in between them, right? Whatever the heck the letters are. Guten bei.
What are we doing for homework?
Oh, thank you. Sorry, my bad. Quickly. People have to go learn about poetry. They're so excited about it. Homework. It's on page 298. And we're going to do numbers 2 through where's the area? What is this? What is today? Today's Thursday? Yeah, that's fine. Sure. Do it. You only got one lesson anyway. 2 through 50 evens. Oh my gosh, you only have one lesson. You'll be fine.
I have so much theater that I have to do though.
Well, you'll have some downtime. I know how theater productions work. There's always downtime. I know there's plenty of things and friends and such to distract you, but you have downtime. So that's how that works.
And then the sound for 3 hours for 9 days straight.
Oh, really? You do
Yes.
it sound as well?
I'm not
Nice.
even on stage, I'm just a sound person.
Ah, see, you've got lots of downtime then.
No, I